More trigonometric ratios, but first with an application of the Pythagorean theorem. So we have about 5 examples here to work. Hopefully you've learned the Pythagorean theorem, that the legs squared, you add one leg squared plus another leg squared, that's the hypotenuse squared. And you've been at least exposed to the definitions of the trig functions, where the sine of an angle is the opposite over hypotenuse, the cosine of an angle is the adjacent over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. So today we're going to work the examples. So let's focus on our first example. You have a right triangle, 90-degree angle, with the legs are 3 and 4. And you want to find trigonometric values for sine A. Well, the previous video we did, we had all 3 sides given to us, but we don't have that hypotenuse this time, and we know. So we're going to call this hypotenuse x and just apply the Pythagorean theorem. So we have the leg squared plus the leg squared is the hypotenuse squared. And that gives us 9 plus 16 is x squared. And we take the square root of both sides, and we get x is equal to 5. So our hypotenuse becomes 5. Okay, now let's look at the definitions. Our first definition is the sine is the opposite over the hypotenuse. So we go to angle A. Let's review again. This side across from the 90-degree angle, across is always the hypotenuse. This side straight across from angle A is the opposite. And then that remains this side, which is touching A. So it's the adjacent. Now this side touches A also, but this is the hypotenuse. So adjacent, touching A, opposite of A is the opposite, and across from the 90-degree angle is the hypotenuse. So with that mindset, the sine of A would be the opposite 4 over the hypotenuse of 5. Okay? The cosine is defined to be the adjacent over the hypotenuse. So the adjacent side to A is 3, and the hypotenuse is 5. Now the tangent of A is defined to be the opposite over the adjacent. So that would be 4 over 3. And there are 3 answers for the trigonometric ratios. Okay? So now we go to example 2. Now, example 2, I've turned this triangle around a little bit, so let's make sure we have a leg 5 and a leg 12, but see, this is the hypotenuse, which we don't have, which we do not have. So we're going to call it the variable x. So we have a leg squared plus a leg squared is equal to the hypotenuse squared. Okay? So this would be 25 plus 144 is x squared. And then if we add the 25 and 144, that'll give us 169. And upon taking the square root of both sides, you will get 13 to be x. So inserting that 13 for the hypotenuse, we then apply our definitions of our trigonometric ratios. So the sine, again, is the opposite over the hypotenuse. The opposite of A is 5. And the hypotenuse is always across from the right angle, 13. The adjacent, or the cosine, is the adjacent side to A. Well, there's A. Remember, this is the hypotenuse, so this has to be the adjacent. So it's 12 divided by the hypotenuse across from the right angle of 13. And the tangent. The tangent is defined to be the opposite over the hypotenuse, adjacent, the opposite over the adjacent, which in this case would be the opposite side of 5 over the adjacent side of 12. And that's our 3 trigonometric ratios. Okay. Okay, let's move to our third example. Now, this is an interesting problem. You're going to learn in a future lesson that this is a special right triangle. Well, we'll hold that to the future lesson, give you something to look forward to. You have the leg and the hypotenuse, but you don't have the other leg. So we're going to call that x. Now, when we apply the Pythagorean theorem, we have leg squared plus the other leg squared is equal to the hypotenuse squared. And this allows us to solve for x. So we have 1 plus x squared is equal to 4. And then if we subtract the 1 from both sides, we will get x squared to be 3. And upon taking the square root of both sides, we'll get x to be the square root of 3. Now, the square root of 3 is not a perfect square, so we'll just write the square root of 3. Now, let's apply the definitions. Remember, the sine is the opposite, square root of 3, divided by the hypotenuse, 2. The cosine is the adjacent. What side's touching angle A? 1 over the hypotenuse. And the tangent of angle A is the opposite over the adjacent. Square root of 3 over 1, which you could just write as the square root of 3. And that'll be a triangle that you will see a lot of in the future. So there's our 3 trigonometric ratios. Okay, that's moving to example 4. Now, example 4, you're given a leg and the hypotenuse, so we need to find that leg. We call that x. And we find angle x, or side x. So we say leg squared plus leg squared is hypotenuse squared. Squaring our 6 and squaring our 10. We have that. Okay, subtracting 36 from both sides. 64. And then taking the square root of both sides, we would get x to equal 8. So we put 8 right here. Now we apply our definitions again. The sine is the opposite over the hypotenuse. So that'd be 8 over 10. And we'll reduce. The cosine. The cosine is the adjacent, 6, over the hypotenuse, 10. And we will reduce. And the tangent. The tangent is the opposite over the adjacent. And we will reduce. So there you go. There's our 3 trigonometric ratios in reduced form. Our last example is another special triangle. There's 2 special triangles. We did one in example number 3, and then we're doing one in example number 5. You're given the 2 legs, and notice they're both the square root of 2. Some of you may have learned that word as isosceles, when you have at least two sides of a triangle congruent. We'll call the hypotenuse x. So we take the leg squared plus the leg squared again. It's the hypotenuse squared. And the square root of 2 times the square root of 2, let me just write this out because sometimes students have a little question about that. And we write it out again. And some people remember if you multiply a square root by itself, you get what's under the square root. That's true. Some people like to see it this way. You multiply the 2 times the 2 and you get the square root of 4, whatever you need. So you may not need these steps. You may be able to go from here to here. But if you need them, use them. Square root of 4 is 2. Another 2 is x squared. And you get 4 is x squared. And you take the square root of both sides. And the square root of 4 is 2. So we find x to be 2. We insert that here. So now, the sine is the opposite over the hypotenuse, which is the square root of 2 over 2. The cosine is the adjacent. Notice it's the same, square root of 2 over 2. And the tangent is the opposite over the adjacent, which is the square root of 2 divided by the square root of 2, which is 1. So there's our 3 trigonometric ratios. Now, these trigonometric ratios are going to allow us to start computing the measure of the angles A. And if we get A, we can get the top angle, the other angle. And then that leads to applications. So I would hope that you can understand this lesson and apply it, and stay tuned for the next lesson.